Hi everyone, and welcome to an introduction video for Geometry Lesson 2.1, using inductive reasoning to make conjectures. Now we're going to jump right into our first example. In this example, they want you to figure out some patterns. And we've done this before, and I think you'll probably find it pretty easy, I hope. But let's see. Example 1, we're asked to find the next item in each pattern. In part A, they give us Monday, Wednesday, Friday. They want you to find the next day that you should name. In part B, they give you 3, 6, 9, 12, 15. What number should be next? And in example C, they give us these lovely arrows. One's pointing to the left, top, top. You have to figure out what's next for the arrows. Okay, they just want one item in each pattern. See if you can also describe the type of pattern that they're doing. So pause the video, try and do that, and then press play to check your answers. Okay, in part A, they're alternating days of the week. So this should be Sunday next. They skipped Saturday. In part B, they're counting by threes. These are also the multiples of threes. This is 3 times 5, so next is 3 times 6, which is 18. And in part C, they're turning 45 degrees clockwise. So the next arrow should point to the top right. Okay, so let's take a look at some term words that talk about what we just did in that example. What you did is you applied inductive reasoning. Okay, you used the process of reasoning that a rule or statement is true because you looked at specific cases. Okay, you drew a conclusion from a pattern that you saw. Okay, so you looked at the cases, decided on a rule, and then said this rule is true, so this is the next thing. Okay, now that rule that you made is known as a conjecture. It's a statement that you believe to be true based on inductive reasoning. And the inductive reasoning approach follows these 3 steps. You start off by looking for a pattern. So in the previous example on the days, it was Monday, Wednesday, Friday. So you look for the pattern. You say, oh, they skipped Tuesday and Thursday. Then you make a conjecture. They're alternating days. They're skipping the day in between. And then 3, you're going to apply the conjecture, show that it's true, or find a reason why it's not. Now, when you come to class, we'll talk about counterexamples and how those can help us show that a conjecture is false. But we're not going to do that in this video. So I just have one last example for you. In example 2a, they ask you to complete the conjecture. It says the product of an even number and an odd number is blank. So what you're going to do is you're going to try several examples. An even number times an odd number. Even number times an odd number. Keep going, several examples, and then see if you can talk about the result of an even times an odd. So you're going to want to fill in the blank with either even or odd. Okay? Try and fill in the blank. And then press play to check your answer. Okay, so the result is even. And what you can do is try several examples, like 2 times 5 is 10. 10 is even. 3 times 4 is 12. 12 is even. And no matter what numbers you pick, the result is always going to be even. Okay, so that's it for this introduction to inductive reasoning. I have lots more examples for us to do in class. I hope this was helpful for you.